It is always an absolute thrill to connect with the Dassault Systèmes community. When I look at this ecosystem, over 400,000 customers and more than 15 million engineers and researchers worldwide who design more than half of the products surrounding us every single day, I feel right at home. I am an engineer at heart. If I were to start all over again today, I'd undoubtedly choose to use SolidWorks. Many people might not realize this, but NVIDIA and Dassault Systèmes have a relationship that stretches back over a quarter of a century. We started working together during the last major computing platform revolution, the migration of Unix workstations to Windows-based personal computers. The technology that made our early collaboration possible was based on OpenGL. We invented a technology called CGFX, the precursor to CUDA, while OpenGL paved the way for the fully path-traced, physically based rendering we have today. And here we are working together once again as we fundamentally reinvent the computing platform for a new era. 40 years ago, Dassault revolutionized the world with the concept of virtual twins representing the physical world inside a computer. Now, we are entering the generative economy, where we are supercharging the virtual twin with accelerated artificial intelligence to represent the physical world at a massively larger scale. We are completely reinventing the computing stack. In the last generation, design representation was highly structured. We manually specified every geometry and every material. Now, we are moving to a generative computing model. Because AI is foundational to every single industry, it is becoming an essential infrastructure, exactly like water, electricity, or the internet. Every industry needs to build it, every country will be powered by it, and literally every society will utilize it. This marks the beginning of a new industrialization. In the past, we might have spent a third of our time in digital design and 2/3 in physical prototyping. Very soon, we will spend 100% of our time in the digital realm. Everything will be software-defined, from a pair of tennis shoes to the cars we drive, the robots that assemble those cars, and the incredibly complex factories where those robots operate. All of these will be represented, simulated, validated, and operated inside virtual twins before a single physical part is manufactured. To turn this vision into reality, NVIDIA and Dassault Systèmes are embarking on the largest collaboration in our joint history. We are fusing NVIDIA's body of work, our CUDA-X acceleration libraries, our AI frameworks for physical and generative AI, and NVIDIA Omniverse directly into the Dassault ecosystem. This will give millions of engineers the ability to work at a scale that is 100, 1,000, and very soon 1,000,000 times greater than what was previously possible. What used to be offline, pre-rendered simulations will literally happen in real time. Let's think about what it means to compute a world model. First, consider biology the most complex system ever created. To build a world model of life, we first have to understand the language of life. Life existed long before us, so we must learn the language of DNA, proteins, and cells. Once we learn this meaning, we can translate between human language and the language of biology. This allows us to use generative AI to create new proteins, new drugs, and new advanced materials that are stronger, lighter, and more heat resistant. We are already seeing this happen with companies like the Bell Group in food science, where they use virtual twins to automatically generate and test non-dairy proteins, fundamentally accelerating innovation while ensuring complete safety. Beyond biology, we have to teach our AI the laws of physics. While we cannot literally compute infinity, we can absolutely imagine it. That is why the fusion of principle-based simulation and AI is so revolutionary. Years ago, I introduced the idea that we could augment traditional physics simulators, which are accurate but incredibly slow, with AI that learns to predict physics. Think of how a dog catches a ball in midair. It isn't doing complex math, it's predicting the trajectory. With technologies like Physics Nemo, we have an AI framework grounded in the laws of physics that can predict outcomes 10,000 times faster than traditional methods. Companies like Lucid Motors are already leveraging this to embed crash behavior, dynamics, and vehicle performance into the earliest stages of their design programs. This scale of simulation extends all the way to entire factories. A factory is not just a building. It is a system of millions of objects, AI agents, and robots working in sequence. Designing and operating a software-defined factory requires immense computing power. Companies like Omron are already using virtual twins not just to visualize, but to engineer autonomous production systems before they are even built, resulting in far more resilient and flexible manufacturing lines. And then there are the AI factories themselves. We are currently undergoing the largest industrial infrastructure build-out in human history. To create the infrastructure for AI, we are scaling 3 massive industries simultaneously: chip manufacturing factories, computer system factories, and finally, the AI factories, giant data centers where the supercomputers reside. A gigawatt AI factory costs roughly $50 billion. Because the stakes and costs are so astronomically high, we design, plan, and simulate absolutely everything down to the thermodynamics, the network routing, and the physical bill of materials in a virtual twin before we break ground. A natural question arises: will this AI replace engineers? The answer is no. It will augment them in ways we could only dream of. AI allows us to seamlessly translate between unstructured data, like an image or a sketch, and structured 3D data. Instead of replacing designers, every single engineer in the future will act as a manager and creator, guiding a team of specialized AI companions. You will train these companions, teach them your preferences, and deploy them to explore hundreds of design optimizations while you focus on creativity and strategy. Your AI companion will codify your unique skills, habits, and domain expertise. It stays with you. I sincerely wish I had an AI companion that could have codified my last 33 years of knowledge. This also changes how we handle compliance and manufacturability. We are shifting left. A standard language model understands syntax and taste. A world model understands causality, inertia, gravity, and physics. By integrating human values, safety regulations, and manufacturing constraints into the world model early on, compliance becomes baked into the design by default. Organizations like Nair are proving this by ingesting complex aviation regulations directly into the design phase, turning compliance from a costly hurdle into a massive competitive edge. We are standing at the precipice of a $185 trillion global industrial buildout over the next decade. Everything must be designed, simulated, and operated intelligently. The vision Dassault Systèmes had 40 years ago is completely coming to life today. By amplifying this massive ecosystem with accelerated computing and AI, we are not just making people slightly more productive, we are making the genuinely impossible possible.